Hello students, welcome to chemistry class. So in the last class we have studied about the chemical reactions of diazonium salts. So in this class let us continue the chemical reactions of diazonium salts, that is reaction with the potassium iodide. So in the last class we have studied the Sandmeyer's reaction and Gettermann's reaction, right? So let us continue the remaining questions of diazonium salts. So this iodine is not easily introduced into the benzene ring, but when diazonium salt solution is treated with the potassium iodide, iodobenzene is formed, that is Ar(N2) plus and Cl minus. So it is to be treated with the potassium iodide. So it gives the product, that is Ari, aryl iodides, plus nitrogen gas is to be eliminated, and potassium combines with the Cl, it gives potassium chloride. That is, in order to attach the halogens, that is like iodine, to the benzene ring is not possible, but the attack of iodine to the aromatic ring is possible through the diazonium salts. So in the previous classes we have studied about the stability of the aryl halides. That is, for example, let us take C6H5N2 plus and Cl minus. So it is to be called as benzene diazonium chloride. So this benzene diazonium chloride reacts with the potassium iodide. So it gives C6H5 and it is I plus N2 gas plus KCl. So it is to be called as iodobenzene. That is, in order to attach iodine to the benzene ring, the diazonium chlorides are to be treated with the potassium iodide. And next reaction with the fluoroboric acid. So the formula for fluoroboric acid is HbF4. So it is to be called as fluoroboric acid. So this arene diazonium chlorides, that is Ar(N2 plus and Cl minus. So it is to be called as arene diazonium chlorides. So this arene diazonium chlorides treated with the HbF4, that is fluoroboric acid. So here the halogen atom, that is Cl minus, is to be replaced by the negative part of the fluoroboric acid. So here the negative part is, that is H plus and BF4 minus. So H combines with the Cl, it gives minus HCl, that is CH hydrochloric acid is to be eliminated. So it gives an intermediate product, that is Ar(N2 plus and BF4 minus, right? So on heating, so these aryl fluorides are to be formed, plus BF3 boron trifluoride is to be obtained, plus nitrogen gas is eliminated. So here the stable product is BF3, that is boron trifluoride. Hence the aryl fluorides are to be obtained from the arene diazonium chlorides by treating it with the fluoroboric acids. For example, let us take C6H5N2 plus and Cl minus. So it is to be called as benzene diazonium chloride. So this benzene diazonium chlorides are to be treated with the HBF4, hydro or fluoroboric acids. So it gives, that is Cl minus is to be replaced by the strong nucleophile, that is BF4 minus. So it gives C6. So BF4 replaces Cl minus, so it gives C6H5 and it is N2 plus and BF4 minus. So on heating, so this C6H5 combines with the fluorine, that is fluorobenzene is formed, plus the byproducts are BF3 plus N2 gas, that is fluorobenzene is to be obtained. And next reaction, that is replacement by hydrogen. Replacement by hydrogen. So in the previous reaction there is a replacement of fluoride ion, right? And in the reaction with the potassium iodide there is a replacement by iodide ion, that is N2 group is to be replaced by the iodide ion. And next let us see the replacement of diazonium group with the hydrogen. So in that first one, that is the reaction with the hypophosphorus acid. Hypophosphorus acid. So the hypophosphorus acid formula is H3PO2. So that is same reaction, that is Ar N2 plus and Cl minus reacts with the H3PO2 plus H2, that is dilute hypophosphorus acid. That is, dilute means the reaction takes place in the presence of water. So it gives, that is hydrogen is to be attached to the aryl groups, plus nitrogen gas is to be eliminated, plus, so this hypophosphorus acid is oxidized into phosphorus acid. So phosphorus acid formula is H3PO3. So it is hypophosphorus acid and H3PO3 is phosphorus acid. Phosphorus acid plus the byproduct is HCl. That is, main product is benzene ring, benzene, aryl diazonium salts to be converted into benzene by treating with the hypophosphorus acids. For example, let us take C6H5 N2 plus Cl minus reacts with the H3PO2. So this H3PO2 on oxidation, that is addition of oxygen takes place. That oxygen is to be released from the water molecules. So it gives C6H5 plus 1 hydrogen, that is C6H6 plus this N2 gas plus Cl combines with the hydrogens, it is HCl plus this H3PO2 to be combines with the oxygen, that is to be called as oxidation of hypophosphorus acid, gives H3PO3, phosphorus acid. Next, reaction with the ethanol. That is the second reaction involving the replacement by hydrogen. So this aryl diazonium chlorides, that is Ar N2 plus Cl minus, is to be treated with the ethanol, that is ethanol is CH3 CH2OH. So aryl group combines with the hydrogen, it gives Ar hydrogen plus these alcohols to be converted into aldehydes, that is CH3, CHO, aldehydes, and this nitrogen gas is to be eliminated as N2, and the Cl combines with the hydrogen, it gives HCl. That is, arene diazonium chlorides reacts with the alcohols, that is alcohols to be converted into aldehydes. That is, when arene diazonium chloride is treated with the mild reducing agent like ethanol, it gives arenes. For example, that is C6H5N2 plus and Cl minus, that is benzene diazonium chlorides treated with the acetic ethanol CH3CH2OH, so it gives C6H5 plus 1 hydrogen, it is H6, plus N2 gas is eliminated, and H combines with the Cl, it gives HCl plus 1 byproduct, that is this ethanol to be converted into aldehydes, that is CH3CHO. Next reaction, that is reaction with the water. So this reaction is to be called as a replacement by hydroxyl group. That is diazonium salts Ar N2 plus Cl minus on hydrolysis, it reacts with the water molecules. So H plus and OH minus. So negative part attached to the aryl group, that is ArOH plus nitrogen gas is eliminated, plus H combines with the Cl, it gives HCl. Simple reaction, that is C6H5N2 plus Cl minus. So benzene diazonium chloride, benzene diazonium chloride, it reacts with the water molecules, so it gives C6H5OH. So this compound is to be called as phenol. So phenol is also to be prepared from the benzene diazonium salts by treating it with the water molecules. So the byproduct N2 plus HCl. And next reaction, that is reaction with the fluoroboric acid. Fluoroboric acid. That is replacement by NO2 group. Replacement by NO2 group. So in the previous reaction, that is the reaction of the benzene diazonium salts with the fluoroboric acid, there is a replacement by fluoride ion, right? So in this reaction, let us see how this NO2 group replaces the diazonium salts. That is C6H5N2 plus and Cl minus. So it reacts with the HBF4. That is to be called as fluoroboric acid. So it gives C6H5N2 plus and BF4 minus, right? So it reacts with the sodium nitrite, NaNO2, sodium nitrite, in the presence of copper on heating. So there is an replacement of diazonium group with the NO2 group, plus the byproducts are, that is sodium combines with the BF4, it gives NaBF4 plus N2 gas is eliminated. So it is to be called as nitrobenzene. It is nitrobenzene. That is, when benzene diazonium chloride is treated with the fluoroboric acid, it gives benzene diazonium fluoroborate. It is benzene diazonium fluoroborate. So followed by unheating with aqueous sodium nitrate solution in the presence of copper, so it gives nitrobenzene.